Hello there, physics class. As promised, if we didn't have school on Wednesday, we would have another video. So we'll make a little bit of forward progress. And today is Wednesday, it's the 27th, and here we go. We have been talking about the relationship between the force of gravity and force centripetal. So let's see. Force centripetal is mv squared over r, and the force of gravity is g m1 m2 over r squared. And it turns out when we have something that is like, say, the Earth, and say the moon is going around the Earth, or a satellite is going around the Earth, or the Earth is going around the sun. So we have this caused by centripetal force, this caused by centripetal force. The Earth is going around the sun, that's caused by centripetal force. Probably in our universe, or in our solar system, in our galaxy, sorry, we have the sun orbiting probably some black hole. So we have all these circular motions that are caused by centripetal force, and in that we've seen several things that can cause centripetal force, but in these cases this force is caused by gravity. So that allowed us to come to this amazing conclusion. When we have force centripetal equals mv squared over r, we can replace force centripetal with force of gravity equals mv squared over r, but we know force of gravity is g m1 m2 over r squared and mv squared over r. Mathematically, we can simplify this. Say this mass is the thing that's going around. We'll say the orbiting mass. This is also representing the orbiting mass. This is the mass of the thing in the center. So these two will cancel mathematically, and when I multiply through by r squared, we end up with gm, mass of the thing in the center, equals v squared and an r. So that's the simplified working model, and this is where it comes from. So we also saw, so nothing new there, that was covered in detail on the last video, and we also saw that period indicated with the t, that's the time to go around once, equals distance divided by velocity. So that was also discussed. And the distance is sometimes not given. Distance around one revolution is, we have to calculate it with 2 pi r. Now sometimes this r, we have to go over here and find it, and sometimes this v, we have to go over here and find it. So it all depends what's given and what's asked for. But somewhere between these two, or a dance, either this one or some sort of dance in between the two, will answer all of the questions. So all that we're doing today is trying 4 problems. So on your sheet of paper, I would like to show you those 4 problems. If you would jot them down and use this information. If you cannot, please revisit yesterday's or the last video or the notes from that video, and you should be fine. Alright, here is, I did several examples. Was it 3? 3 examples like this, so hopefully you can get through these problems. Alright, on the first one, so write this one down. It said the Earth's year, or period, is given. That's how many seconds are in a year. I bet you were worried and wondering about that. And the Earth's orbital radius is given. And we want to calculate from that information the sun's mass. Now, if you recall, we actually did that exact problem on the last video, but I wanted you to try it on your own and see what you get. and you can go back to the last video and check your work, or find out how to do it if you're stuck. Alright, again, use the formulas that I just mentioned, and you will be able to calculate the sun's mass. Alright, second one is a newer one. Here I am giving you the sun's mass, which you're going to use from problem number 1 above, and Pluto's orbital radius is given, and find Pluto's orbital period in seconds, and then change it to years. So the period is t equals d over b will give you a good start on that. Alright, let's look then at the third one. On the third one, we have the Earth's mass given. The satellite there's a satellite involved, and its orbital radius is given. So when I say orbital radius, that includes the diameter of the Earth as I pictured there. So you don't have to make any adjustments to that. And you need to find the speed, or we call it velocity in our formula, of the satellite. Alright, and the last one. Here we are at Jupiter, who has a moon called Io. So the orbital period of Io is given. And I also changed it to seconds. So that's how long it takes to orbit Jupiter. And if Io orbits Jupiter at a radius of given, then what is the mass of Jupiter? Right, so our formulas will give you all of those. That was number 4. So our formulas will, either one or both, will give you the answers to all of these questions. So write them down. Say you cannot do them even after you watch the video again from last time. Please draw a picture, write down all the information, write down what is given, what is asked for, so that I can see that you put some effort into it, and at least give me a formula that you think you would start from, but I'm sure you can get much further than that. Okay, happy physics class. I hope that you enjoyed some time in the snow, and I bet I'll see you tomorrow. So that's Thursday. Sounds like a good day to start back. All right, till then, over and out.